In the last video, we defined cosine and sine using a triangle in the unit circle. So we had a point here, and this hypotenuse here is a radial line between the point on the edge of the unit circle and between the origin here. And when we have an angle between the x-axis and this line of theta, we can define the position of this point as cos theta and sine theta. Importantly, writing this point as cosine theta and sine theta, this works at all angles. That means it doesn't just work in this region here where the angle is between 0 and a right angle. It works into this second quadrant, and it works through into the third and fourth quadrants, and we can also turn around multiple times, and this point here, cosine theta, sine theta, will still be true. In the last video, we looked at a point that's described by an angle of pi on 3. So that's a third of half of a turn, or a third of a straight angle. So we could write this point with an angle of pi on 3 as cosine pi on 3, sine pi on 3. And when we did that, the sides of these triangles, and you'll have to believe me on this, are the square root of 3 on 2, and this side here is a half. So that means we can write this point as 1/2 and root 3 on 2. So what happens when we draw a mirror image of that triangle on the other side? Well, firstly, this angle here isn't pi on 3, it becomes twice that, so it's 2 pi on 3 is the angle here. And since this whole angle here is pi take 2 pi on 3, so a pi take away 2/3 is pi on 3. So the coordinates of this point in a trigonometric form will be cos of 2 pi on 3 and sine of 2 pi on 3. If we want to write exact values for this coordinate here, just like we did over here, what we can do is we can look at the lengths of these sides. So the length of this bottom side here, is 1 on 2, just as with the other side. The length of this vertical side is root 3 on 2, just as with the other triangle. So if we want to write the position of this point, it's 1/2 of a unit. However, it's on the negative side, so the coordinate is minus 1 on 2. And the y coordinate is root 3 on 2 away from the x-axis, and it's in the positive y region, so this one just stays as positive root 3 on 2. So root 3 on 2. So that's our new coordinate. You'll note that when we have our angle in the second quadrant here, what happens is that we end up having values of x over here that are negative. However, the values of y here, they're staying positive. And we'll look at that a bit more in the next video when we start to look at what happens here in the third quadrant and also in the fourth quadrant.